CoAP protocol originates from the REST, representational state transfer. CoAP doesn't use a centralized server as MQTT does, but every single device hosts a server on its own to provide available resources to the clients asking for a service offering distributed resources. CoAP uses UDP comparing to MQTT that uses TCP, and is stateless, thus doesn't require memory for tracking the state. The CoAP implementation assumes every single IoT device has a unique ID, and things can have multiple various representations. It is indeed to link things together using existing standard methods. It is rather resource-oriented, not document-oriented like HTML, designed for slow IoT networks with a high degree of packet loss, also support devices to be periodically offline. To identify a service, CoAP uses Uniform Resource Identifier, shortly URI, similar to the Uniform Resource Locator that we use daily when entering the website address to the browser. URI uses by CoAP has the CoAP protocol identifier first, eventually CoAPS for secure encrypted communication, like HTTPS in web browsers. Then comes the other part of the URI, identifying server address, port, and also a query like in the HTTP GET request. The protocol is designed to be compact and simple to implement. The stack implementation takes only about 10 kilobytes of RAM and 100 kilobytes of storage. The header is only 4 bytes. CoAP protocol has a binary header to decrease overhead, but payload depends on the content type. CoAP can handle various payloads like text, link, XML, octet stream, JSON, and many others. Because CoAP uses UDP instead of the TCP and is ready for non-reliable connections, it must ensure a mechanism to recover correctly order and delivery status. Because of the nature of UDP datagram communication, messages are exchanged asynchronously between two endpoints, transporting requests and responses. Messages may disappear, just get lost, appear duplicated, or even being delivered unordered. Because of it, CoAP messages can be sent and received as confirmable ones, so they need an action from the receiver side, to obligatory send back an acknowledgement message. Non-confirmable, so they do not need any action from the receiver. By the two types, there are two more. One is just acknowledgement message, while the other is a reset request. The last one appears when the receiver got a message, but doesn't understand its context. In the example, when some previous messages were not delivered, but they are essential to recover full information. This reset message shall inform transmitter to repeat communication from scratch. Empty reset message can be used as a kind of asynchronous pinging between sender and receiver. CoAP also provides an efficient yet pretty straightforward reliability mechanism to ensure successful delivery of the messages via stop and wait for retransmission with exponential backoff for confirmable messages and duplicate message detection for confirmable and non-confirmable messages. In any case, request and response pair, if present, are identified by the unit token, usually increased over time with every next message.